Here we go. Example 5. This is exercise 17A. You are now finding for the first time the derivative. The derivative. So I'm going to write here just to remind you, this is the derivative. To find the derivative. Now the rule that I gave you, first principles, f dash of x is equal to the limit of h approach 0. This is your y2 minus y1 divided by x2 minus x1 ends up being h. That's the rule. Okay? Now, let's have a look. What we need is we need f of x, which I have. They told us that f of x is equal to x squared plus 2x. The next thing you need is f of x plus h. So if I work this out, f of x plus h, what is that equivalent to? This is where I often try to teach function notation here. That x is where all these x variables are. What you're replacing right now is you're replacing, and I'm going to highlight it, you're replacing x plus h for every one of these x values. That's what you're doing. Yeah? So this gives you, instead of x squared, it is now x plus h squared. Plus, instead of 2 times x, is now 2 times x plus h. Okay, it's just like what you would have done if I said, what is f of 1? What you would have done is you would have replaced all the x squared, all the x's with a 1. That's how you would have done it. So why would it be any different if I sub in x plus h? Should be the same idea, right? So, what you want to do here is, the more you simplify, the easier it is to do later. So here, you should be expanding, and that's why I'm saying all the questions you're going to do will have to do with quadratics or cubics. So let's expand this. For those who've forgotten, square the first term, square the last term, which is what most people have. What they tend to forget when you're expanding quadratics, remember there is 2 times x times h. So that gives you 2xh. So remember the a squared plus 2ab plus b squared. That's what I'm using there. And expanding this now becomes 2x plus 2h. So I'm multiplying that. Can you simplify anything? So let's see, there's an x squared. Can't do anything there. There is a 2h with a h squared. So I'm just going to plus h squares and plus 2h there. But notice here, I like to write these two together. Can someone explain why? Why did I rearrange these two? Because you can factorize. Very good. Can you see these two terms? They're actually the same. These two are x's, but they have a variable h. Another way of writing this is you can factorize this, and that now shows you you've got x squared plus 2x times h plus 1. Can you see that? So that way you know that that's the coefficient, or that's the coefficient. Another way of looking at it as well is you can look at it as 2 times h plus 1 of x. That's another way of thinking about it. So this is your coefficient of x, and then that means this is your constant. That's your plus c. So it's kind of like ax squared plus bx plus c. That's another way of writing it, okay? But just for your sake, I'm just going to simply keep them all in separate terms. But I want you to, later on, that's what we do. We look at quadratics and use quadratics for it. So here we go. That's what we've got. Let's put it all together now. According to the rule, f dash of x is equal to the limit of h approach 0. F of x plus h, we've now got x squared plus 2xh plus 2x plus h squared plus 2h. We're minusing f of x. And what was f of x? F of x is over here. That was x squared minus x squared. And don't forget, you're also minusing the 2x. Okay, because you're minusing every single term. So all of this is out of h. If you simplify this correctly, you should be fine. Remember, don't forget to write limit of h approach 0. Let's see what we can cancel out. X squared minus x squared cancels out to be 0. H squared, no, there's nothing there. 2x minus 2x cancels out to be 0. So what am I left with? I'm left with 2xh plus h squared plus 2h all divided by h. And this is the skill that I've been giving you that time. It's about 20 minutes to practice. How do you find the limit of this equation? Hopefully you figured out h divided by h is 1, h squared divided by h is h, and h divided by h again is 1. This now gives you limit of h approaches 0. 2x times 1 is 2x plus h plus 2 times 1, which is 2. Now you can apply the limit. So from here, I'm going to zoom out a bit just so you can see what we did. This is your f of x plus h minus f of x. I've simplified them. I've cancelled out the h denominator. Now, what happens when h approaches 0? This is the only thing that gets affected. So that means what if it infinitely becomes smaller and smaller and smaller? What does your result approach? Very good. So that is the step that you would find. Now, I want you to remind you, this is not the derivative at one point yet. This is the gradient function. I'm going to write here, write in your notes. This is called gradient function. So on Wednesday, I'm going to be teaching you how to use this gradient function. Okay, so this is called a gradient function. Whenever that x is on the curve, you sub it in, and that allows you to find the gradient at one point, instantaneous rate of change. Okay, but right now I'm just going to get you to practice. This is called first principles.
So at the end, it does equal 2x plus 2.
Yeah. That's assuming that this infinitely becomes smaller and smaller and smaller. Then 2x plus an infinitely small plus 2 is approximately 2x plus 2.
Do we have to show all that working out?
Correct. That's why this exercise is tedious.
You don't have to in each solve.
No, because it's not on the study design, but it's the idea of what is this actually doing. So once you understand what this is just infinitely getting 2 points close to each other. So when I teach you a shortcut, which you no longer use this anymore, when I teach you shortcuts and rules, if you're wondering why we learn those rules, is because you don't want to be doing this. This takes too long to do, and there are shortcuts to figuring that out. So when I look at this, I can derive that, and I know it's 2x plus 2 straight away. You can, and that's what I'm saying. So most students will learn the how. Everyone will learn how to differentiate the how, but what most students lose out on is the application. Why they find derivatives hard is because they don't get it. So all of you will learn how to differentiate. You can become masters. You become masters of finding how to find the derivative. If you can't even derive, that's when I know you're getting about a 25 and below. So when you can derive, that's the expected. On average, everyone will know how to derive it, the shortcut. A lot of people don't understand what you're doing. So just because you can find a shortcut doesn't mean you can apply. The problem is, in year 12, 3/4 of your course is applying it. So most students will do the first step, which is to get here. And it's like, what do you do with that? That's what the problem is. So I'm spending time to make sure you know the theory, and then when I start showing you the shortcuts, you can then apply. So right now, that's what I mean. I want you to understand it as it's a gradient function, and on Wednesday, I'll unpack that with you to understand what the derivative does, and you can learn all the shortcuts you want, get really proficient at it like everyone will, but you'll have an extra step to it so you understand what it actually does.
So if I have to do the working out, can I just do x to the power 2 minus 1 and 2x to the power 1 minus 1?
Where'd you get that from? X to the power of...
No, none of that. I just want to write 2x plus 2.
Yeah.
No, not just that. Like, if I was going to write my own working out.
Oh,
can I
here.
just do, yeah, x to the
Oh, you're
power
using
2.
the shortcut.
Yeah, can I just write that?
Oh, no.
I have to use
I still want you to do this. Because it reinforces y2 minus y1, x2 minus x1. You're going to be doing whatever you just described, literally all of from here on. This is the one session that I'm getting you to do that. And you never have to do it again, but you have to practice the algebra, the simplifying. That's what I want you to do.
But we have to do that in the SAC.
If we put it in the SAC. But now that you're deterring against it, I may tell the other teachers, I'm like, I want it in there.
No, yeah.
And I have a lot, I'm taking a leadership role in this year 11 methods course, so I can choose what I want in that.
So bossy.
Yeah, so you gotta watch it. I might put 10 marks for this question. Just for the sake of it's like 1 mark, 2 marks, 3 marks, 4 marks, 5 marks. Just for the sake of it. And if everyone complains, I'll be like, because some student, not naming anyone, but everyone will know, like not naming anyone, someone inspired me to make sure it's in the sack.